Hi, so today we're going to start our new unit, Kinetics and Equilibrium. We're going to focus on chemical kinetics today, so this is our topic right now. What I'm hoping you take away from today are the 5 factors that affect how fast a reaction is going to occur, also known as the reaction rate. So we're going to talk about those 5 factors and do a couple practice questions. So chemical kinetics. Just a recap from earlier in the year, kinetics means movement. So we're really focusing on particle movement again. But chemical kinetics is a fancy term for talking about the speed of a reaction or the reaction rate. Just like in math class, a rate is the measure of speed over a certain amount of time. Again, we're just trying to study how fast a chemical reaction is occurring and how can we affect how fast a reaction is occurring. Maybe we want to speed it up so that we get our products faster. That's typically what scientists are going to do in a lab, for example. Or maybe we want to slow it down for some reason. However, all chemical reactions come down to collision theory. This is something we briefly talked about earlier in the year, but chemical reactions only occur if particles are colliding. If you have more particle collisions, the faster the reaction is going to go. Less particle collisions, the slower the reaction is going to go. But what we're looking for with a chemical reaction is effective collisions, meaning particles are colliding with the right amount of energy and in the proper orientation. They have to have both proper energy and orientation in order for a reaction to occur. There's 5 factors that we're going to talk about that affect the rate of reaction. The first one, nature of the reactants. This essentially means it matters if we have ionic compounds or covalent compounds. It matters if we have an acid or a base reacting with each other, so on and so forth. But during a chemical reaction, bonds are going to be broken and reformed. Thus, the type of bond that's forming matters and will affect the rate of the reaction. The second factor that's going to affect the rate of reaction is the concentration of the reactants. Remember, concentration, it's just a measurement for how many particles we have. So if we're talking about a solution, molarity is going to measure how many particles we have in X amount of liters. But what you need to know is as the concentration of the reactants increases, there's more particles. If there's more particles, you can have more collisions. There's more of a chance for particles to collide with the proper amount of energy and orientation. And if all of that comes together, the rate of the reaction is going to increase. So increased concentration, we increase the rate of reaction. The third factor we're going to talk about is temperature. Temperature is always a go-to in the lab for making a reaction occur faster. Remember that temperature is also called average kinetic energy. So if we increase the temperature, we increase the average kinetic energy, meaning our particles are moving faster and they're moving around more. We thus get more effective collisions. If we have more collisions, we increase the rate of the reaction. So if we increase temperature, the overall reaction rate is going to increase. And again, it's because we have those effective collisions. Our fourth factor, which we've talked about before, is surface area. So if we increase the surface area of the reactant, again, there's a few ways to do this. We can chop up the reactant, we can grind it with a motor and pedestal, but if we have more surface area, there's more area for the particles to collide on, and we're going to increase the reaction rate. And factor number 5 is going to be our newest term, catalyst. Now, you definitely talked about catalysts in biology. Our bodies are filled with catalysts. Catalysts are a substance. It's a chemical substance that is not a part of the chemical reaction, but is used to lower the activation energy. So we have 2 new terms. Catalyst, a substance that lowers the activation energy. Activation energy is a fancy term for the initial amount of energy that a chemical reaction needs in order to occur. So think about it like when you light a match. There's a certain amount of energy from striking the match on the matchbox that is needed in order for it to catch fire. Every reaction needs that little bit of energy in order to occur. Catalysts are helpful because they're going to lower the amount of energy needed, which allows the reaction to proceed. They do so by providing what's called an alternative pathway. So they lower the activation energy. There is now a new pathway for the reaction to occur, thus speeding up the reaction. So for catalysts, 2 things to commit to memory: lower activation energy by providing an alternative pathway. So overall, here is our 5 factors that you need to know that affect reaction rate: nature of the reactants, concentration, temperature, surface area, and catalyst. And you need to know how each of these is going to affect the collisions of our particle and thus our reaction rate. If you have any questions, as always, let me know. Have a good one.